guys, welcome to 2.7 inverses. We're going to see how do you know if two functions are inverses. We learned this last year and it had to do a little bit with Fogg and Goff, if you recall. So an inverse, basically that's just reverse or the opposite of a relation, and we find the inverse by interchanging or switching the variables. Inverses are going to be reflections over the line y equals x. You need to know this. A vertical line test is going to tell you whether a function is, or whether a relation is a function. And the horizontal line test is going to tell you whether your relation has an inverse that's a function. And we're going to practice those two tests. Here we go. Here's some nice graphs. First of all, we're going to check to see if these guys are functions. That's the vertical line test. Draw a vertical line, crosses one time, so yes, he's a function. Draw a vertical line, crosses one time, so yes, he's a function. Draw a vertical line, crosses two times, so no, he is not a function. Now we're going to go check the other way. Let's see if they have inverses that are functions. Horizontal line test. Go across with a horizontal line. He does not have an inverse that is a function. Go across with a horizontal line. Yep, his inverse is a function. Go across with a horizontal line. Yep, his inverse is a function. So graphically, that's one way to tell if you have an inverse or even if you have a function. Now, to verify that two relations are inverses, you will use composition, and you have to get x both times. That's Fogg and Goff. So let's practice that. Remember, we just talked this week about Fogg. And what you do with Fogg is you take G and you shove him into F. So here you go, G. We're going to shove you right there into F. So F is 3 times x minus 5. And then we're going to stick good old G in there. And then we're going to simplify using just algebra. Well, you know from middle school that a 3 on the outside and 3 on the inside, one on top, one on bottom, those are cross-canceling. And that means them go away. So I just have x plus 5 on top and minus 5 outside. 5 and minus 5 makes 0, so I'm left with x. Ooh, this is good news. They might be inverses. We got x, but remember we have to do both Fogg and Goff and get x both times. So Goff means that you're sticking F inside a G. So here's F. We're going to shove him into G. Well, G starts out with x plus 5 over 3. And let's go shove F in there. F is 3x minus 5. Well, negative 5 and positive 5 cancel to make 0. And then 3 divided by 3 is 1. So we get x again. So yes, these bad boys are inverses. Now how do you find an inverse? Switch x and y and then solve for y. So in this question, we want to find his inverse, but there's not a y in the problem. No fear. F of x does mean y, so we start with y equals 3x minus 5. And since we're trying to find the inverse, we will switch the letters. Y becomes x, x becomes y, and then we just solve for y. So I'm going to add 5 to both sides. x plus 5 is 3 times y. Now I got to get rid of the number in front of y, which is 3. So divide by it. So I get x plus 5 over 3 is equal to y. And then we should be good students and write that as f, since our function was f, inverse. Remember that little -1 means inverse. And we got x plus 5 over 3. That's the answer. That's the inverse. So we've looked at some ways to tell if things are inverses, how to tell if a graph has an inverse function, how to find an inverse and verify if they're inverses algebraically. Now we're going to do that with a graph, and this is pretty easy. Here's a nice parabola, and I have some points on him. Those are your nice little points. And to find an inverse, you switch x and y. So -2, 4 becomes 4, -2. -1, 1 becomes 1, -1.